Morning, afternoon, evening, as the case may be. Hi, I'm Shruti Kulkarni. I'm Information Security Architect with Alexon. And the topic of my presentation for today is the rise and rise of non-human identities. Here is the agenda for our presentation. We first talk about non-human identities, what they are, what does it mean to have a non-human identity. Then we'll talk about the rise and rise of NHIs and also the reasons for the rise of them. We'll talk about a little bit about why do we need NHIs? Can we get away with not using NHIs? Not so much. I mean, we'll see why we really need NHIs for the kind of world that we are living in. And then we'll also look at what can go wrong with this NHIs and what kind of preventive controls we can have and the detective controls and the takeaways for you from this presentation. Let's start with what a non-human identity is. But before we start on non-human identity, we also need to know what an identity is. So this is how NIST defines an identity. It's a set of attribute values by which an entity is recognizable. We need an entity to be recognizable and distinguished from any other entity so that it is unique. That's what this definition is saying. So extending this to non-human identity, and this is a definition provided by CyberArk. Non-human identities are digital entities that are used to, again, they are a set of attributes again, but they're used to identify, authenticate, authorize machines, devices, IT infrastructure, applications, cloud workloads, all such things in an infrastructure. They are actually typically they include any digital identity that is not associated with or operated by a human. As we'll see going along as we go into our presentation, NHIs, it's very easy to create NHIs automatically and scale them up and down to meet the needs of the business. So, what constitutes a non-human identity? So, non-human identities have attributes, very much like human identities, as we discussed in the previous slide. So, examples are, if you create a RPA bot, these will have identities created in an identity provider database with attributes like type of identity, software used by the bot, and the administrator of the bot. So another example of this is a container. So to have a container, we need an identity with attributes like the name of the container, the registry in which it is located, the tags, hash, and sometimes obviously, yes, if you have a hash, you also need the algorithm for the hash. And then CI/CD pipelines use identities with attributes of names, permissions, and privileges. The examples, I got them from the sources which I have attributed on the slide. Here are some pictorial depictions of what a non-human identity looks like. If we have a server and the server runs an automated process, so we want to automatically start and stop this process. We can't do this, with human entity. Because, first of all, we can't really work on an automated fashion to start and stop the service based on a preset criteria. And then we might fail, we might forget. And it is also not very efficient, neither from time nor from effort perspective. So what do? We use a service account, which then runs the process. So in this scenario, we have the service account as the NHI, and the attributes are typically, I'm saying, a username and a password. You could use any other attributes as well. Here is another example of NHI. This is more current, actually, in today's world. Assuming, a user wants to upload a file to an S3 bucket. This is an AWS environment, as you can see. So the user wants to upload a file to an S3 bucket, and which triggers a Lambda function, and which in turn puts in a notification and publishes it to the end receiver. Whilst we see all these things, the S3 bucket, the Lambda function, and the SNS, they all have roles. Those roles are actually NHI, and the attributes include the permissions assigned to the role and the temporary credentials. So what I mean by that is, when the S3 bucket triggers the Lambda function, what it can do is it can just trigger it and run the Lambda function. It cannot delete the Lambda function. Similarly, when the Lambda function puts in a notification in the SNS, it has permissions only to do that. It doesn't have permissions probably to delete the notification. So this is what I mean by permissions. And These are the attributes of the NHI. Let's set some boundaries and scope. This presentation is all about NHIs used in IT infrastructure, and we'll touch a little bit about on OT, IoT, and smart home devices. But what we are not going to talk about is any synthetic identities created using AI or any other identities created using AI, because that's a very different topic in itself. Let's talk a little bit about how human identities and non-human identities are kind of similar and yet different. So both have attributes, as we saw in the earlier slides. Both need authorization to access resources. Typically, I've not come across any scenario wherein an identity can access a resource without any authorization. There may be anonymous authentication, but nonetheless, it's still an authentication and then authorization to access the resources. And both can be abused. However, because non-human identities are used for programmatic access, and there is no human intervention, applying a preventive control like MFA is not always an option. And unlike human identities, it's challenging to have visibility to all the non-human identities on the estate. This is because many times environments are spun up and stood down based on the demand, based on where they are in their sprint, based on what is currently being used, the stage of the development of the solution. So when, obviously, because environments have to be spun up and the services in the environment need to be spun up, or the assets need to be spun up. Identities, or these services and assets need identities, and so they get created too. But always a cleanup may not take place when the environment is stood down. So we may have lingering orphaned identities in the environment. And it is very challenging to get visibility to all those non-human identities on the estate. We'll get now to the center theme of the presentation. That's the rise and rise of NHIs. That's what I call it. NHIs have grown really, really multifold in the recent past. And this is because this is one of the reasons. There are many other reasons, but this is one of the reasons. The increase in digitization and increasing collaboration is bringing about an increased use of NHIs, because automation and collaboration, integration and stuff, they need NHIs. We cannot manually do that kind of a integration and collaboration. Also, not all tasks can be carried out manually. We need some level of NHIs that can carry out these tasks without any human intervention. So automation is required. Like, for example, we use RPA bots because we are in such a digital world and there are so many processes running in our environments. We need someone to keep an eye on it. We need someone to create digital workflows. So all that is done through automation. RPA bots, such like, can help in that. And they have, as we saw earlier, they've got identities. The functioning of some applications and services require NHI. For example, the good old web application. Now, when a web application is configured on a web server, the web server actually runs on a service account. If you have done it in a traditional, good old-fashioned way of enabling an Apache server or IIS on machine, so that needs NHI. And also, when web applications reach out to databases, they also need a service account. As otherwise, it's not possible for a human being switching to the web application and then connect to the databases. So, for functioning of applications require automation or NHIs. Then there is an increasing need for programmatic access. As we see the world shrinking from a digitization perspective, there's a lot of data exchange, data interchange that takes place through programmatic access. It may not just be through for data exchange. It may also be for increasing collaborative work by using SSO, etc. They need API calls, and then machine-to-machine communications need NHIs. There is an increasing amount of integration between OT, IoT, smart home devices. We have a splurge of smart home devices nowadays. I think at a minimum, most homes have multiple devices like iPads, iPhones, or laptops, and then we've got smart lights, we've got smart bulbs, smart switches, etc. So all these need identities and they have attributes. That's what I'm trying to say. And increasing cloud adoption, the use of microservices and DevOps. So you see where I'm going with this and where I'm coming from. All this has led to the rise of NHIs. At the surface, it may seem, yes, microservices, DevOps, CI/CD pipelines, cloud adoption, yes, but all of these actually are driven by communication that do not require human intervention and many times by adoption of APIs. And APIs need NHIs. That's why we've got a rise of NHIs. So we talked about automation using bots, we talked about increasing programmatic access with APIs, talked about digital workflows. And then this one, I would like to spend a bit of a time because increasing needs for a single pane of glass. Now, there are several tools that offer representation or rather bringing together of metrics and KPIs on a single pane of glass because we all want to know the health of our systems, be it IT, OT, IoT, not smart home devices. Not everybody has a single pane of glass in a smart home device. Though, of course, that is increasing with home automation systems. So, we need, with all these integrations, we need to know the health of the system and how the capacity and then the usage of resources, everything. To bring together all these metrics and KPIs onto a single pane requires, again, a lot of integration. And you make use of API codes. There is another use case for single pane of glass that is actually raising events. For example, if we see an alert in cloud environment, we would want to be alerted on our Slack channel, probably create a Jira ticket automatically. They all need API integrations. So again, as you see where I'm coming from, so is a lot of such activities, automation, integration, collaboration, digitization that's going on. So this will lead to rise of NHIs. And this is not going to go slow down anytime soon. It's, if at all, there will be an increase and not a decrease of NHIs. Now, I'm not saying ease of creating identities is a reason for rise of NHIs, but it is a contributing factor because if there were a whole lot of difficulties in creating these NHIs, I would guess that would have slowed down quite a bit. But then with the ease of creating identities, the ease of creating API keys, the ease of creating private-public key pairs, and then the cost of certificates, coming down, which has, as you know, public-private key pairs, all these actually are a contributing factor to the rise of NHIs. What can go wrong with so many NHIs around? You can have an identity sprawl, and there could be abuse of identities. And we'll touch upon identity sprawl, which, it's actually uncontrolled creation of identities and environments. And the reason for this is, why I call it what can go wrong is that there is a difficulty of applying joiners, movers, leavers processes to creation of identities and environments. As I touched upon earlier, in today's world, when solutions are being created, developed, deployed, maintained, environments are spun up and spun down automatically. And of course, as these environments do have services and assets, they need identities. Now, when you create all this, then not usually a cleanup may not happen. So you may leave SSH key. Not just you. Generally speaking, SSH key, sorry, not SSH keys. That's the wrong word to use. So public-private key pairs may be left lying around. API keys may be left lying around or in some old forgotten vaults. Then we may have certificates which are expired, but we don't want to delete them. So these things are left lying around. And that's what I call as an identity sprawl. And it's very challenging to go and discover all the public-private key pairs or all the API keys, or unused API keys, retrieve them and then delete them or disable them or whatever can be done with it. It's a very challenging and daunting effort. So that's why, you see so many attributes of identities, being spread around. It may have an impact, but does it lead to any kind of a threat materialization? Maybe not. Maybe it might lead to some issues with resource utilization and all, but does it lead to any kind of a data exfiltration or any kind of identity spoofing or identity theft? It may. It depends on how the keys are being dealt with or how the identities are being dealt with. But we will touch upon that actually once we, in the next coming slides, as to what we can do about, such identity sprawl. If we can't prevent that from happening, how do we address it? Now, abuse of identities is quite common, be it human or non-human identities. Identities get abused. So API keys, someone might steal the API keys and then use them maliciously. Service accounts, especially if they've got interactive logon enabled, they may be, assumed by a human user. Roles, AWS roles can be assumed by a human user. Managed identities can be compromised. Then there is always the easily available secrets, like not being negative about all these things, but nonetheless, sometimes secrets do get embedded in code, embedded in container images, which can be acquired maliciously and then abused. Then there is this general non-expiry of credentials as well for non-human identities. That's another aspect. I'm not saying, not every credential or every identity that is issued has non-expiry credentials. Azure actually forces you to rotate, expires your keys that you use on a regular basis. But many a times it doesn't happen. So that's another aspect. And the key one is the general lack of second factor authentication that can be applied to these identities. For example, if an API key has been compromised and you don't know about it, you can't really use a step-up authentication to understand whether the API request is a genuine one or not. Of course, all these things that can go wrong, the abuse of identities and all, has an ancillary impact in terms of exploitation of data or manipulation of code and configuration. However, we'll not touch upon this because that is not the intent of this presentation. I wanted to include them more from a completeness perspective. Let's look at preventive controls, detective controls, and then we'll talk about the conundrum. So we are all told about preventive controls for identity management. That is, the key one is using least privilege, only allocating that many privileges and permissions that the role or the identity needs, and then to manage the identity lifecycle. There is another security property of educating anybody who uses secrets, keys, passwords to tell them that, they need to be secured. However, the conundrum is this. Normally, all automations are not really complete automations because there could be failures in automation, and those would need to be addressed. To do that, administrators need access to the environment, and administrators need full access to the environment. Now, why this becomes a conundrum is that I'll take specific examples so that, we can all relate to what I'm trying to say. We have an AWS environment and an administrators who are looking after the environment. They have access to everything, including the IAM policy. Now, if there is an insider threat, or if there is a malicious actor who has compromised the credentials of an administrator, they can go ahead, edit the IAM policy, allow themselves to assume the roles of the services, and then use that to carry out malicious acts. For example, in the earlier example that we saw about the roles for S3 bucket, Lambda function, and SNS service, a malicious act could be the malicious person assuming the Lambda role and then setting a notification to the end service and the end user saying that the file upload is complete without it being completed. It's really challenging to prevent that because of the full access that the administrators need. There's another example to it. Administrators have view access to production service accounts, for example, in an environment. This is for Azure. When administrators are in the environment, read access cannot be taken away. The problem is if you have read access or view access that allows you to download data to your laptop. How do we prevent that? This is what I'm saying, the conundrum. So there is a lot of automation, there's a lot of collaboration and all that because of inadequacy and addressing the failures in automation and the need for administrators to have full access to the environment. Some of the preventive controls may not really work as well. Then what do? We fall back on detective controls. But these need to be tailored to the situation, very, very tailored to the situation. For example, how do we detect compromised API keys? So I know there is a preventive control to do that is rotation of API keys. But what if you have a 1-month rotation period and the day after you're rotated, the API keys are compromised? How do we detect if an IAM policy has been modified leading to assumption of roles? And then how do we detect a poison container accessing another not-poison container? How do we detect public-private key pair? A compromise of public-private key pair of a machine identity, a compromised keys of a certificate probably used by an API, and the good old compromised credentials. How do we detect the compromised credentials of a service account, especially the one that has interactive logon enabled on it and is being abused by a malicious actor? The key thing to remember over here is that compromise of attributes of an NHI may lead to threat materialization. Not invariably, I'm sorry, I've written it over here as leads to threat materialization. It may not always lead to threat materialization, but many a times, more often than not, the compromise of the attributes of an NHI may lead to threat materialization. And this is what we will see how to detect. And then you twist the process that we may have the security processes to allow us to address any kind of a compromise of NHIs. So, for example, let's assume that in a hypothetical scenario, abuse or compromise of the credentials of an NHI leads to data exfiltration from a database. If we have an environment and we have an endpoint which has a database running on it, now we know database applications cannot run on their own. They need accounts, service accounts, to run the processes that the databases have. Now, if service account has been compromised and the service account has local admin access with interactive logon enabled on it. Now, obviously, what this means is that the malicious actor who has compromised the service account has full access on the server on which the database is running. And with interactive logon being enabled, they can assume the role of the service account and carry out processes. So there are certain on-the-edge processes, like for example, if the malicious actor wants to exfiltrate data from the database, they got to copy it onto something. So usually that something would be a notepad or a wordpad. You may want to detect the word processor process being spun up, but that could lead to a lot of false positives because database administrators may want to spin up word processes. So wordpads or notepads. So again, I'm weaving the story in between, so bear with me. Now, let's start from the beginning. So supposing the service account is compromised and then the service account has local admin access with interactive logon enabled, the malicious actor starts a notepad process and copies the data on it. That is not of much use to the malicious actor. They have got to send it out to their location or wherever they want to consume the data from. So that would need the malicious actor to create an outbound internet access connection to probably their storage, external cloud storage. What we need to detect is the establishment of the outbound internet connection from the database server. That is because there is no business case, there is no use case for any outbound connectivity to be established from that server to an external personal cloud storage. Word processor or notepad? Yes, probably, but not outbound internet connection, unless it is allowed for a business reason. In which case, of course, there will be different kind of detective controls that can be set in. Well, all I'm trying to say is that there is usually a story when NHI is compromised. And we need to actually identify that story and then understand what we really need to detect to work out if an NHI has been compromised. Let's look at another example. So for example, you've got an API that is invoked from a geolocation that is not in scope. Hypothetically, we may have a predefined process which needs to process from the backend. Now it uses an API to make a call using an API key and carry out the process on the backend and return the results of the process to a database. Now, because this is a predefined process, it's a programmatic access, it may have a geolocation that is defined and fixed. However, if a malicious actor compromises and acquires the API key and creates a web page, for example, and calls the API from a JavaScript using the API key, and then tries to acquire the results of the process and use it for themselves. Now, this also has a storyline. API key is compromised. It's really very challenging to detect that because there are no indicators of compromised. However, the location of its invocation can be detected because the IP address would be different. So the predefined process, which I have got over here, would be run from a defined IP address or a range of IP addresses from a particular location because it's a programmatic access. A human user might use it from a different IP address. So detecting the IP address of the location of the API invocation would be very helpful in detecting if an API key has been compromised and is being used maliciously. And usually, more often than not, a large number of API requests would be made because the malicious actor may not fully know what and how the backend process results are being sent out to as a part of the API response. So again, there is a storyline. When we look at the NHIs and then the compromises, the conundrum that we have got, and preventive and detective controls, we may want to look at the whole process of applying preventive controls and detective controls in a slightly different way. It's always good to identify threats via threat modeling and implement preventive controls. So far so good. However, we may want to ask ourselves a lot of questions, and one of them would be, which of the identified threats would materialize with a compromised NHI? That will tell us what we really need to detect, what the storyline would be if a particular NHI is compromised and what it could lead to, and then identify a set of alerts that would help us detect the threat materialization and then work with the SOC team to create alerts. I'm not saying this is silver bullet and it addresses all scenarios. Maybe it needs tweaking. However, we need to appreciate the kind of situation we are in, the growth of NHIs that we see, the business demands for collaboration, or even infrastructure demands, IT demands, solution demands for collaboration, for automation and all, and then understand the impact of what could happen if the NHIs were compromised. Then take a step back and look at what we can do. What are the preventive controls? What if the preventive controls fail? And how are we ever going to detect the compromise of an NHI, and how would we address them? So these are my final thoughts. NHIs are not going to go away anywhere anytime soon. They're going to increase and their credentials will need to be secured. Preventive controls are not enough. So we need to threat model the solution, look for what can go wrong if NHIs are compromised, and design detective controls to complement preventive controls. That's all I have. Thank you very much.